AI applications rely on APIs to connect users, agents, models, tools, and data. That makes APIs both powerful and exposed. In this topic, we'll secure that control point with gateways, tokens, rate limits, bot defenses, and threat protection. We've already built the foundation: identity, permissions, secrets, secure development, prompt protection, and model integrity. Now we move to APIs, where those controls become runtime enforcement across users, agents, RAG pipelines, and model endpoints. APIs are more than pipes into a model. They are security boundaries around data, tools, costs, and autonomous actions. If that boundary fails, attackers may steal data, manipulate outputs, trigger tools, or exhaust the system. Threat modeling and AI API starts with one question: who can call it? That includes people, machines, service accounts, agents, and partners. From there, map what each caller can reach: data, prompts, tools, retrieval, and file inputs. The AI-specific concern is downstream impact. A single request might trigger RAG, tool execution, model extraction, or automated abuse. So before choosing controls, evaluate cost, data exposure, privilege escalation, and overload. The API gateway is the controlled front door to your AI platform. Every client request is checked before it can reach costly models, tools, or data. The gateway verifies identity, applies authorization and tenant policies, routes traffic, transforms requests, and enforces rate limits. It also creates consistent logs, traces, and request IDs. By concentrating these controls in one managed point, teams reduce duplicated security logic and gain clearer monitoring across services. At runtime, the gateway becomes the enforcement checkpoint for each AI call. It confirms who is calling through tokens, MTLS, keys, or federation. It validates the token, authorizes scopes and tenant claims, and rejects anything outside policy. It also inspects payloads for schema, size, and content while applying throttles and quotas. Approved requests carry their security context forward to model or RAG services, and every decision is logged for audit. Every JWT should be treated as untrusted until it passes validation. Start by verifying the signature with trusted keys and reject unsafe options like ALG none or weak algorithms. Then confirm the issuer, audience, expiration, not before time, and token type. Only after those checks should claims be used for decisions: tenant, user, roles, groups, scopes, and assurance level. The takeaway is simple: identity from the client is just data until cryptography and policy make it trustworthy. Scopes translate a token's permissions into specific allowed actions, such as chat invocation, file upload, retrieval, tool execution, or model administration. Claims add context, including tenant, role, region, data classification, and assurance level. The goal is least privilege. One token should not unlock unrelated data, models, and admin functions. Check access at the gateway, then repeat those checks inside backend services. That layered enforcement limits damage if a token is overused or stolen. Tokens should be treated as temporary keys, not permanent credentials. For higher-risk AI actions, such as tool calls or data retrieval, access tokens should expire quickly. Refresh tokens need stronger protection: secure storage, rotation, revocation, and conditional access. Where replay is a concern, bind requests to evidence such as a nonce, timestamp, proof of possession, MTLS, or DPAPE. If risk changes because of a suspicious user, unhealthy device, or tenant change, reduce privileges or revoke access immediately. Rate limiting for AI APIs has to be multidimensional. Counting requests is not enough, because one request can consume thousands of tokens, invoke expensive models, or start long-running compute. Strong controls combine limits by user, tenant, IP, service account, and endpoint. They also adjust based on trust level and risk. When a limit is reached, respond safely, typically with 429 too many requests, without revealing details that help attackers tune their abuse. Adaptive throttling treats AI usage as a real-time control problem. Each request is evaluated against token limits, tenant quota, model cost, platform load, and anomaly signals. Low-risk traffic can proceed normally. Higher-risk traffic may be slowed, routed to a cheaper model, challenged for verification, or blocked. Circuit breakers are especially important because agents can loop, retry failed tools, and burn tokens quickly. Connecting these controls to billing, FinOps, and security helps turn cost spikes into detectable events. A WAF is valuable in front of AI APIs, but it has to be tuned carefully. Standard rules should block injection attempts, malformed requests, suspicious headers, invalid methods, oversized payloads, and known exploit signatures. High traffic adds nuance because prompts may legitimately contain code, URLs, logs, or unusual text. File uploads and retrieval calls also need inspection. The goal is layered protection. WAF filtering, schema validation, authentication, content checks, and rate limits, tuned to avoid unnecessary false positives. Bot protection acts as a security checkpoint for API traffic. Each request brings signals such as device fingerprint, velocity, IP reputation, session history, and behavior over time. Risky traffic does not always need to be blocked immediately. It can be slowed, challenged with CAPTCHA or proof of work, or sent to step-up authentication. Trusted service traffic should use stronger identity, such as signed requests, MTLS, and workload identity, so legitimate automation moves smoothly while scraping, credential stuffing, and probing are contained. Effective AI API security is operational, not just architectural. Teams need to know who called which endpoint, under which tenant and token, and what happened afterwards. Combine normal API telemetry with AI-specific signals, tokens, prompts, models, retrievals, and tool calls. Then baseline behavior so spikes, denied scopes, failed prompts, or unusual tenant patterns stand out. Response should be rehearsed. Revoke tokens, throttle tenants, isolate endpoints, update WAF rules, and preserve evidence before the trail disappears. The main lesson is that API security turns AI controls into runtime enforcement. Gateways, validated tokens, least privileged scopes, throttling, WAFs, bot defense, and monitoring work together to control access, reduce abuse, and manage cost. Next, we extend that protection to the data flowing through AI systems.